Well, we've seen how GML can be used to display text on the screen, can be used to declare variables, and can be used to ask for information from the user and then store that information in variables and then display that information on the screen. I want to show you an example here of actually drawing an image on the screen using GML. So we're going to create a new script. To save time in terms of this video lesson, I've already created the script, and I'll just show you how it works and explain what's happening. So I've created a new script called ser_shapes, and then I'm using some built-in functions in GML to write some statements, pass some arguments to the functions, all of which are going to cause us to draw a rectangle and a circle on the screen. So let me show you what I've got inside this script. First, what we're doing is we're using one of our draw functions, just like our drag and drop draw function. This one I'm setting the color for the thing I'm going to draw, and I'm setting the argument to a red color, which is also built in. Then I'm saying I want to draw a rectangle, and I'm defining the size and the position of that rectangle. That's what these X and Y coordinates are. What I'm doing is I'm going to actually create this script, and then I'm going to connect the script to an object. I will place that object out in my room, and then what will happen is that from the position where I place the object in the room, I'll draw a rectangle right around that position. So whatever the position is of the object I place in the room, we're going to say that we want our rectangle upper left-hand corner to be at the current position minus 50 in the X, and then the current position minus 50 for the Y. And then the other corner will be the current position plus 50, and the current position Y plus 50. And then this false means that we do not want to draw a border around our rectangle. Then we do the same thing here. Again, we're setting a color, this time blue, and now we're going to draw a circle. And the position of the circle is just going to be right where the object is that I place on the room. That's what this X and Y means. And then the 40 is the size in pixels of the radius of that circle. All right? And then again, I say I don't want to have any border drawn around the circle. So that's a lot going on in there. Let me show you what it looks like. So here's our script. I'll close it out. I'll come back to our controller object, and then it's still sitting here with the hello you script, and you can choose to, in testing this, either leave that active or you can remove the controller object from the screen. But now you'll see we've got a new object, object shape. And for this object shape, I'm going to do a couple of things. One is I've got no sprite attached to it, so in a way it's working like our controller object does, right? There's no sprite we're associating with it. Instead, we're going to create the sprite through the use of that script. I'm still going to have a create event, and I'm going to set this shape object to moving around the screen. So I do a move free event action, and I set the direction to be a random direction in any of 360 degrees, and I set the speed to be a base of 4 plus anything from 0 up to 3. So we'll have slightly varying speeds. Then I've got a draw event, and my draw event now is going to actually create and draw the rectangle and the circle. So I say execute script, and I choose my shape script. So let's see how that all happens. Coming out to my room, here's my object controller. I'm going to go ahead and get rid of that. We don't need that. And here is my shape object. I've already got one placed out there. I'll place a couple more of them around. Say OK, save it, and then let's run it and see what this looks like. So here we have it. Here's our room. We saw the objects quickly fly off the screen. So they're being created, but I'd like those to not disappear like that. So we're going to do a wrap screen that we've used in previous projects, and we'll do it in two versions. First I'll do the old version, which is using the drag and drop, and then I'll show you how to accomplish the same action using GML. So coming back into our game file, I'm opening up the shape object, and I'm coming to the draw event. And if you remember, the draw event works similar to a step event. It happens repeatedly 30 times per second. And I'll come on my move palette down to the jump section and use the wrap screen and choose in both directions. Save that and run it. And now when our objects are moving around the screen, if they exit one side of the screen, they should reappear on the other side of the screen. So here we are. Here are our objects flying around, disappear off one side of the screen, and then reappear on the other side of the screen. So we've used the drag and drop version of the wrap screen action. How would you go about doing the same thing using GML? In order to make that happen, we need to talk about the use of conditional statements. So what are they exactly? So conditional statements control whether or not a given action is executed in the program. And a conditional statement uses the form if, so an if statement, if something is true or something is not true, then we tell the game maker to do something. We give it some statements. So here's a way to set that up. Conditional statements have in them comparative operators. So in the section where we say if and then expression, inside that expression we'll use these conditional comparative operators. For example, less than. So if some variable is less than another variable, or some variable is less than a number, then we will do some action. If something is less than or equal to another thing, we'll perform an action. And then we've got this something that looks like two equal signs, means equal to. So if one thing is equal to another thing, then we will perform some action. And then conversely, we can put an exclamation mark and an equal sign, which means not equal to or unequal. So if one thing is not equal to another thing, we'll perform some action. And then if something's larger than another thing, or something is larger than or equal to, then we'll perform some action. So you'll make use of and see these a lot in conditional statements in order to check whether or not you're going to perform some action. We also have combined comparisons. So for example, if I want to check whether two things are true, I can use this pair of ampersands, which means and. So if one thing is true and another thing is true, and another thing is true, and another thing is true, you can string a bunch of checks all together, then perform some action. And then you have an or comparison symbol. If something is true or some other thing is true, then perform an action. And then we have an exclamation mark, which means not. All right. So here's some example. I'm going to open this up. So I've already written a script here. And this is going to be a wrap screen script. So it's going to perform the same thing as our wrap screen action. So look at this conditional statement here. I'll open it up over here as well. Oops, that's my shape script. I've created a script called scr underscore wrap screen. And in this script, I've just got the same thing I've got over here. So I've got a conditional statement, actually a couple of them. And let me explain what's going on here. So I've written a script, and this script I would attach to our shape object in the draw event. Right now we've got a pair of actions, right? We've got our action that draws the shape, and then I'm using a drag and drop action for wrapping. So I could get rid of this, in fact we're going to do that in just a minute, and replace it with another execute script which will execute this script we've got right here. So I want to end up with the same functionality. So if you think about the idea that this script is going to be attached to the shape object, and we've got multiple shape objects out placed around in our room, that helps set up how this is going to work. So we start off with a conditional statement. So we've got an if, and then we have an open parentheses and a close parentheses. And then inside that, you'll see we've got a couple of checks here. First, we have one check that says if the x position of the shape object is less than 0, and that's what this symbol means, the horizontal speed of the shape object that this script is attached to is also less than 0, then we're going to set the x position of this shape object to 640. So what's happening exactly? The idea here is that if the x position of the shape object is less than 0, what that means is that we've moved off the left side of the screen. And also, if the horizontal speed is less than 0, that means that the shape object is moving to the left, right? We remember thinking about both direction and speed. We've talked about that in the past. If the horizontal speed is more than 0, it means the object is moving to the right. If the horizontal speed is less than 0, it means the object is moving to the left. So if we're moving to the left and we go off the left-hand side of the screen, then we're going to set the x position to 640, which is the right-hand side of the screen. So that takes care of an object moving from right to left, getting it to be wrapped around and repositioned on the right side. Here we're doing the same thing, only with an object that's moving from left to right. So if an object is moving to the right, that's what the horizontal speed greater than 0 means, and if the object has moved off of the right-hand side of the screen, we know that by checking if the x position is greater than 640, then we'll set the x position to 0, which is the left-hand side of the screen. So this script takes care of the wrapping horizontally. Let me show you what this looks like. If I come out to my shape object, we go to the draw event. Let's delete out the drag and drop version of our wrap screen, and we'll come down to the control tab and we'll grab a execute script and we'll select our wrap screen script. Now we don't have a full wrap screen script working, right? All we're doing now is setting it up the horizontal version, but let's take a look and see what that looks like. So here are our objects moving around. If they go off the top or the bottom of the screen, they're gone forever because we haven't taken care of that yet. But if they go off the left or right, then they reappear appropriately on the other side of the screen. So what I'd like you to do before we go on is in your own file set up the horizontal wrapping, and then I want you to see if you can figure out how to modify what we've got here for this conditional statement so that we will wrap the object when it's vertical. And pause the video, go in and give this a try, and then hit play again, and once you hit play, I'll paste in the code. So this is just a self-check to see if you can figure out how to do that. Go ahead and give it a try. Okay, did you figure it out? I've added in the code here for vertical wrapping, and you'll see, not surprisingly, it looks very similar to the horizontal wrapping. Now, however, we check to see first if the y position of our object is less than 0 and the vertical speed is less than 0. That means the object is moving from the bottom of the screen to the top of the screen and has in fact gone above the top of the screen. Then we set its y position to the bottom of the screen. And here, if it's moving from top to bottom, the position is greater than the bottom of the screen, then we set the y position to the top of the screen. Let's take a look quickly to make sure everything's working as we think it's supposed to. So here we are. We've got our objects moving around. Whether they go off the left or right of the screen or the top or the bottom of the screen, they appear appropriately on the opposite end of the screen.